Hello, my name is Aditya Vardhan, and this is a video for the CG assignment 4. My teammates include Arjit Singhal, Gagan Agarwal, and myself, Aditya Vardhan. So, in this video, I'll demonstrate how this football game works. Uh, so, first, we have a scene initialized with 4 app obstacles, namely earn, a car, a spare, and an old fashioned teapot. We have football in the middle. The players' positions are initialized randomly at first. On the left side, we can say that we have player 1, on the right side is player 2. We have 2 goals, one on the left and one on the right. And now let me show you what all a user can do. So this is a multiplayer game. So the two players, player 1 and player 2, the one on the left and right side, can move independently. And any player can catch the ball. Like player 1 can catch the ball using key press Q. And then he can carry the ball wherever he wants to. And then he can dribble using key press F. And then finally he can shoot using G. And once the ball gets out of field, the screen is refreshed. The car obstacle takes some time to load. Because this section I think needs a bit more computation. Okay. And the same operations can be performed by player 2. The player 1 can move by W, A, S, and D, and player 2 can move by up arrow, right arrow, left arrow, and right arrow keys. Player 2 can catch the ball using P, key press P. And then he can carry the ball along with him, and then he can dribble it using key press J, and then finally he can kick it using key press H. Now, when the ball is kicked, the other player can catch it if he is near the ball, using the same catch command, P or Q, depending on the player. So let's say player 2 take the ball using key press H, player 1 can catch it, and then he can perform the same commands, dribble, carry, or just kick. The screen gets refreshed again. And apart from that, each player can rotate. So with the card of cycle load, and then we can perform the corresponding movements. Okay. So the first player can move by a simple open bracket and close bracket. And the second player can move by open square bracket and close square bracket. Now, these all are, so we are done with the movements of the players. Now we can see what happens when the ball collides with the obstacles. So after colliding, the ball goes in some random direction, and when it goes out of field, the screen again gets refreshed, and the screen is reset. So, and let's say that while going in some random direction, it again hits some other obstacle. Then it will choose, and then it will again choose some random direction, and it will follow along the path.
This meeting is being recorded.
Now, apart from all the movements that we just saw that the players can perform, we have 3 perspectives. The one that we're watching right now, and the perspective of player 1, which can be activated using key press N. The player can move, the player can rotate, and then we have perspective of player 2, which can be activated using key press M. He can also move, he can catch the ball, carry it, kick it, and then again the screen will be refreshed. So now that we have seen all the movements and the perspectives, we have 4 different light modes. The first one is the mode in which we can manipulate the speed lights. The second mode is the mode in which we can manipulate the searchlight of the ball. Then we have the corresponding spotlight for both the players that are set in front of their eyes. So in mode 3, we can manipulate the street lights. We can turn them off by pressing 0. We can turn them on by pressing 1. We can increase the intensity by pressing plus, decrease the intensity by pressing minus, and then we can perform similar actions for other lights also. For example, when we go to mode 4, we can manipulate searchlight of the ball. We can increase its intensity by pressing plus, decrease its intensity by pressing minus, and we can turn it off, turn it on. You can observe the searchlight movement by looking at the movement of the ball. Let's see that. See, as the ball moves, the searchlight also moves. When it is dribbling, then also searchlight moves accordingly. And then we can kick it. The searchlight follows, the ball goes along. And then we have the spotlight connected to the player's eyes. We can observe the movement of the spotlight when the player rotates. Observe what happens to the object, to the obstacles when we rotate the player. Then we can see the movement of the spotlight connected to the player. Okay. Now, apart from this, we can also zoom in and zoom out the camera and rotate the camera using the trackball movement. We can zoom out by scrolling, zoom in or zoom out by scrolling, and we can click and drag for rotating the camera however we want to. Okay. So these are all the operations that can be performed by a user using this or playing this game. Okay, so one thing I forgot to demonstrate is that one player can snatch the ball from other player while the ball is dribbling or being carried by the other player. So let me show you. So now the ball is being carried by player one, and then the second player can come and snatch the ball from him. And let's say player two is dribbling the ball, and player one comes and snatches the ball from him. So that's it for the game demo.
Recorded.
In this video, I'll give you a code walkthrough. So apart from the index.js, we have this lib folder in which we have 5 files. 3d.js actually just stores the export classes from the corresponding files. We have camera.js in which we make our camera class, which inherits from the perspective camera class of 3.js. And in this, we just call the super constructor of the parent class with field of view, the aspect ratio, near plane, and far plane values. And then we have light.js, in which we make a light class, which inherits from the point light class of 3.js. In this constructor, we pass light ID, string, and position, list of 3 values x, y, and z. In this next constructor, first we call the super constructor of parent class, in which we pass the light color, which is set to white here, the intensity, and the distance value. Then we set its position according to the given position parameters. We set its name and its visibility to true. And we have this compute limits function, which we were using in our previous assignment to compute the bounding box of each point light source. But this is not needed here. Maybe we have kept it just in case. Then we have render.js, where in which we make a render class, which inherits from the GL render of 3.js. In this, we just call super constructor. Next up, we have scene.js, in which we make a scene class from which inherits from the scene class of 3.js. In the constructor, which is called the super constructor of the parent class, and then we set the material properties. This we used in the previous assignment, and we have an added function of add light, which adds a point light to the scene according to the given parameters. Finally, we have an index.js. In this, we first import the needed modules. Then we create a camera object, set its set position. Then we create scene object, render object, set the canvas size. All of this we do is we just set up a scene. Then we add a spotlight with the white color, light, and intensity 2. This spotlight is used for player 1, and this spotlight is used for player 2. For now, we just add them to the scene because the player objects have not been yet loaded. Then we set the background color of the scene. Then we make an object loader object and a texture loader object, and we save the file path of the stylized grass or JPG in grass texture and the file path of stone or JPG in rock texture. This will use for setting up the texture of a football field and an obstacle, a square obstacle that we have used. Then we make a function called load obj, which takes up an MTL file, which will be used for assigning the properties like ambience, diffuse, and specular properties of the object. Then we have an obj file, which consists of the actual shape that is to be added. Then the JPG file, which is used for assigning texture, a name, so that we can address it with that name later. Then scale, position, and rotate parameter. In this function, we first create an empty loader object and call its load function, in which we file the MTL file, in which we pass the MTL file, and once this MTL file is loaded, this function is executed. So in this function, we mainly create an obj loader object and call it set materials properties to set the materials that have been loaded from the MTL file, and afterwards we call the load function, which takes up the obj file, which has the actual shape, and once that shape is loaded, we execute this function. So in the object, we traverse through each of its child and assign the corresponding texture. We set the name, the position values, the scale values, the rotation values, and finally add that object to the scene. And then we have the load mesh object, load mesh obj function. So what is the actual difference between this load obj function and load mesh obj function is that in load obj function, we are using the MTL file for assigning the material properties to the shape. While in load mesh obj function, we are using this set material properties that we define in scene class for assigning the material properties to the shape. So this load mesh obj function is the same as what we use in our previous assignment. What we do is once the file is loaded, once the shape is loaded, we execute this function. An extra thing that we have done apart from what we did in the last assignment is just that we are assigning the texture here, which we didn't do in the last assignment. So that's the only extra thing that we are doing in this function. Apart from that, all of the things are same. We assign the material property, we map the texture, we set the color, we set the material properties, we set the position, scale, and rotation values, and also if the object is layer 1 or layer 2, we assign some random positions for them when the screen is set. And then we finally add the object to the scene. And here we load all the objects as needed: the field, layer 1, layer 2, football, a car that will be used as an obstacle, the urn and old teapot shape, a square, and the two goals from the left and right. And then
This meeting is being recorded.
so after loading all the objects, we just create a line which is used for bifurcating the field. So it's this line that we have created that is bifurcating the field into two halves. So and then we have an offset value which I'll tell you what it does. Uh, so now we have a get ball function. This function is used for when a player tries to catch the ball using key press Q or P. So this takes in a player parameter and a ball parameter. It computes the bounding box of the player and the position of the ball. Uh, if the parent of the ball is not seen, then the position is assigned with ball.parent.position, and then we check whether the ball is in the bounding box of the player that is passed as the parameter. So it's not actually the bounding box of the player. We take a bit bigger size than the bounding box of the player, for which we use the offset value. This just acts as a buffer, so that player doesn't need to go actually very, very near the ball to just get the ball. Even if he gets uh, significantly near the ball, decently near the ball, he can catch it. So if the ball is in the bounding box of the player, then we get the world position of the ball. And if it's the player is player 1, then we have a player with ball variable which is set to player 1, and the ball is added as a child to player 1. And if the current player and if the player parameter is not player 1, then we do the same operations for player 2. Okay, and then we convert the world position of ball to the local position and assign it to the ball POS variable, and then we set the local position of the ball with what we have computed. And in this case, we set the anim ball kick, anim ball dribble, and anim ball render as false. These are just variables which denote whether the ball is currently under animation or not. And then we set the relative position of the ball in Y and Z so that it looks good in the scene. And then we add point light sources in the scene, which will act as street lights. Then we make a trackball controls object for controlling the camera location using the trackball.
This meeting is being recorded.
So now this is a dictionary of keys. What I'll talk now. About this function I'll talk at some later point in time. So now these are some important variables. This is a flag variable about which I'll talk later. Camera player 1 is the camera for the perspective of player 1. Camera player 2 is that for the perspective of player 2. In it, I'll talk later. These are the variables in which I'll store player 1, player 2, and ball object so that I don't have to do scene.getObject every time. This is the list of obstacles. The card is where urn and the teapot. And this is like a dummy object, a dummy 3D object in 3JS that we have made to set the target of the camera that we have put for players 1 and 2. So SP at 1 will be the dummy object, which is the target of the camera for player 1, and SP at 2 will be the target of that of camera player 2. SP ball is the spotlight which we have reserved for ball. It's actually a searchlight which will follow the ball wherever the ball goes. So we have set its at some initial position along Z-axis at 4 units, and we have set its visibility to 2. Then we add this spotlight or searchlight for the ball to the scene. We have different light modes as in in different modes we can manipulate different set of lights. Light mode actually stores the index to this list of light modes. So if light mode is 0, then it implies that we can manipulate street lights. If light mode is 1, then we can manipulate searchlight, and so forth. Now here we detect the key presses. So the first thing that I want to talk about is about the dictionary. So whenever a key is pressed, we enter a key value pair in this dictionary. So let's say we press key Q. So this dictionary keys will have an entry of Q true, which implies that Q has been pressed. And if we have an entry, we have a key press P, let's say, then it will have an entry P true. And let's say that it had an entry Q is equal to false. This will happen when Q is released. That is when our code detects a key up. We do that here. I'll show you. So we detect key up, and if so, then we set its corresponding key value pair in that dictionary to false. So the value for corresponding keys might be true, might be false. And if the key value pair already exists, and a key press is detected. Let's say Q was false initially, and a key press Q is detected right now. So an already existing key of Q we already have in this dictionary. So we set the value of this key value pair from false to true. So this is what happens in this dictionary key. So we maintain this dictionary to detect multiple key presses, so that we do this so that we can move both the players player 1 and 2 simultaneously. Let's say if Q and P both have pressed down simultaneously, then we perform the corresponding operations simultaneously. So this is what we do. This is what happens in the dictionary, and this dictionary is used in this function check keys, which is called in the animate function. These key presses are continuously detected in real time, and corresponding operations are performed in real time. So what we do in check keys here is that if init is equal to 1, I'll talk about this later what this init is. So for each key value pair in this dictionary, if value is equal to false, then continue. That is, if the key is not pressed, if that key value pair entry, if the value is false, that is, if that key is not pressed, then we don't do anything. However, if the key pressed is A, then if flag is equal to 0, now what is this flag? This flag is set to 0 according to the perspective that we are viewing from. Like if we are viewing from the top view, in this view, then the flag is set to 0. If we are viewing from the perspective of player 1, then the flag is set to 1. And if we are viewing from the perspective of player 2, then the flag is set to 2. So if the flag is set to 0 and if a key press A is detected, then we move the player by 0.05 in the negative x direction, and we move the corresponding camera as well. Else, if flag is equal to 1, we move the player along y, uh, along positive y by 0.05. So let's look at the gaming app. So we do this for intuitive motion. Let's say we have the top view. So in this view, intuitively, because by pressing A, the player should move left, which is in the negative x direction, and that's what happens here. However, in the perspective of, when we go to the perspective of player 1 and then we press A, intuitively the player should move left, which is along positive y direction. That's why we move along positive y direction. The flag is set to 1. And similarly, intuitively, when we are viewing from the perspective of player 2, when pressing A, when pressing A, the player in front of us should move to the left, which is negative y direction. So that's why we perform different operations depending on the value of the flag. And similarly, we perform similar operations for the key presses of D, W, S, and when we press and if an open key press open bracket is detected, then we perform simple notation that we did in the last assignment. Actually, we did trackball notation, but before doing trackball, we actually did key bound notation to check if our quaternion notation was working or not. So what we actually do here is we take a quaternion, we make quaternion object, we calculate the quaternion depending on the rotation that we perform, and we then apply that quaternion to player 1, and the camera of the corresponding camera as well. We apply that quaternion to the corresponding camera as well. So this is for counterclockwise rotation, and this is for clockwise rotation, and then we perform similar operations for player 2 for arrow left, arrow right, arrow up, arrow down, and open bracket and close bracket. And if a key press of Q is detected, then we simply call the get ball function that we discussed above. It actually sets the ball as a child of player 1, and this one sets the ball as a child of player 2. So that's what happens in this check keys function, which we call in animate, and detect the key presses in real time. That's how we perform. That's how we include this multi-key detection process. So now I was going to talk about the init variable. So init is basically a temporary variable, which when it is set to 0, then it implies that none of the key has been pressed. Whenever in our gaming app, the first key press is detected, be it any key, this will be set to 1, and certain initializations will be performed. This we have done just to ensure that the initializations are performed after all the objects have been loaded, so that we don't get any kind of undefined or not found error. So first we set player 1 and player 2 to the corresponding object, and then we add this temporary object that will be used as the target of the corresponding camera of player 1, and then we set its relative position. We do this similarly for player 2. We pass all the obstacles to this list, and we assign the ball object to this ball variable. We set the target of the searchlight of ball with the ball itself. Then we set the camera of player 1. We actually set the camera by positioning it at certain position and updating its look at, rotating it accordingly. This is all setting up the camera. This is all setting up the camera for player one. This camera will be used as a perspective to see from the perspective of player one. This is uh, and this is all for setting the camera that will be used to see from the perspective of player two. And if event.key, if the key press is B, then set the flag to 0, that is top view. If key press is N, then we set the flag to 1, that is the perspective of player 1. If the key press is M, then we set the flag to 2, which is the perspective of player 2. Now, if we press F and the player who has the ball right now is player 1, then we do the following. We set the increment to true, count to 0, and anim ball dribble to true. So these are just the temporary variables that we use for computation. Basically, what we do is we set the anim dribble, that is the dribble mode to true. And if the key press is J and the player who currently has the ball is player 2, then we again set the anim ball dribble to true. That is we activate the dribble mode. And if the key press is G and the player who currently has the ball is player 1, then we find the current local position of the ball, add the ball to the scene, and then we set the anim ball kick, that is we activate the kick mode. Similarly, we do when the key press is H and the player who currently has the ball is player 2. We need to find each time the parent of the ball is changed, we need to find its current local coordinate, because what happens is when the parent of the ball changes, its position attribute is set according to the coordinate system with respect to its parent. That's why we need to update the position attribute each time the parent changes. Now, if the key press is 0 and the light mode is set to street lights, then we set the visibility to false of all the street lights that we initialized above. And if the light mode is searchlight, then we set the visibility of the searchlight of the ball to false. And similarly for the spotlights related to player 1 and player 2. And we set the visibilities of all these lights to true when in case 1 is pressed in accordance with the light mode at that time. This was just for testing. This is not needed. And if we press a key with value 3 and greater, then the light mode is set accordingly. Like if we press 3, then the light mode is set to 0, and that is we get if light mode is set to 0, then we have street lights. If we press 4, then light mode is set to 1, which is searchlight, as we discussed above. And if we press plus, then the intensity of the corresponding light mode is increased by 0.05. And similarly, if we press minus, the intensity is just decreased by 0.05 of the corresponding light of the lights in the corresponding light mode. So that's it. And in check keys, we have also checked this condition if init is equal to 1. That is, if we have passed that level of pressing down the first key, then we need to update the spotlight connected to player 1 repeatedly. And update the spotlight means update the positions of the spotlight and update the target of the spotlight repeatedly, because the targets may change, and this will be done in real time because this is done in check keys, and this check keys is called in animate function. So this will be done continuously. And similarly, we'll update the various position and target attributes of spotlight 2, that is for player 2. And if ball is undefined, then we return. If ball is undefined, then we return. And if it is not, then we set the target of the searchlight of ball to ball itself. All of this will be done continuously. That's it. And then we have anim ball kick, anim ball dribble. This is to denote whether the kick mode is on or not, whether the dribble mode is on or not. This is to store the current player who has the ball. These are only some variables for completion. This stores the initial position of the ball, and this stores the final position of the ball. So this will discuss. So let's take a look at animate ball.
This meeting is being recorded.
So now in the animate ball function, first we check if the ball is neither kicked nor dribbling, and if it is neither collided, then we simply return. And if the ball is kicked, then if the current player with the ball is player 1, we simply move the ball along the positive x-axis. Else we move the ball along the negative x-axis. And if after moving, if it collides with some obstacle, which we check here, then we perform certain operations. And while the ball is moving after kicking, we add certain rotation to it. Now, how do we check if the ball has collided to some obstacle? We run a loop through each of the obstacle. And first, we compute the bounding box of the obstacle, and then we check if the ball is in that bounding box. If it is, then we set the kick mode to false. We set the collision mode, which is actually the collision mode, to true, and we store the initial position, that is the current position of the ball, in init ball pose variable in this variable, and we compute some final random position, and if the x position that we computed in a random manner is equal to the current position of the ball, then we increase it by some amount so that the slope that we calculate using these 2 points, init ball position, final ball position, is not infinity. So this is all that we do when a ball is collided with some obstacle. And if the collision has already happened, uh, then we check if the next computed position of the ball has again led to certain other collision of or not. If it is, then we again compute the final random position and move the ball along the line connecting the initial position, final position of the ball. And how we move the ball along that line is what we have done here. So first we compute the slope in this manner, and if the final x coordinate is greater than the initial x coordinate, we move the ball by 0.06 along x, along the positive x, and set the delta x value to 0.06. Else, we do these operations along the negative x direction. And then we compute delta y by multiplying slope in delta x and set y position of the ball accordingly. And in this animation, in this collision mode as well, we add a slight rotation to the ball, which will be performed continuously. Now, it's because this animate ball function is called inside the animate function. So all of this that we are doing will happen in real time. That is, it will happen continuously as long as the game is running. So here we have discussed the collision, we have discussed the kick. Now we come to dribble. If the ball is in dribble mode, and if increment value is false, if it's true, then set the z value of ball, increment the z value of ball by 0.0. Now, as I've told that the position attribute of the ball changes when its parent changes. So when it is in dribble mode, it means that the ball has one of its layer as its parent. And in that mode, if we change z, then actually in the scene it will look like that the x position of the ball is changing. So doing this will actually look like incrementing the position of the ball by 0.01 along x direction in the screen. So we increment it and we increment the count, and once count reaches this value, a certain value, this is according to us what value that we set. We reset the value of count to 0 and increment value to false. That is, if increment value is false, then we need to decrement it, decrement the ball position in the negative direction, because when we are dribbling, the x position will increment for some time and then decrement, then again increment, again decrement. This is what we are doing here. We are incrementing the value for some time and then we are decrementing it so that it appears like it's dribbling. And this mode as well, we have added some notation to it. And then this is the last function, refresh screen. This function is also called an animate function. This is to check in real time whether the ball is outside the field or not. So we compute the bounding box of the field, and if the ball is outside the field, then we refresh the screen once. This variable is just to ensure that this refresh screen is called only once, exactly once, after the ball has gone out of the field. Since if we don't use this variable, this refresh screen function can be called multiple times as it is called in the animate function. So that's the end of our code. Thank you.